All right. Shh. Thank you, Chris. Can you remind me what we learned about last lesson? Can you remember? So we learned about arithmetic sequences where you're adding and subtracting by the same number. What's the new sequence that we learned about? Was that, sir? Yeah, you try to find the next number. We learned about a new sequence. So instead of adding, adding, subtracting, I'm going to ask Chris. What is Chris? Starts with G. Geometric. Cool. It's called a geometric sequence. Sienna, can you explain to me what's a geometric sequence?
Slowly, faster.
What's a geometric sequence? What are you doing with geometrics? Don't remember? So if arithmetic is add subtract, what would geometric be? Well, it's the opposite of addition and subtraction. Multiply. Good. So with geometric sequences, we are multiplying. Yeah. Does anyone remember the difference as well with the graphs when it comes to arithmetic and geometric? So it's in this slide right here. Kane, what's happening with the geometric graph? Have a look at it. Kane, I just asked you, man, what's happening with this graph? It's going up. Is it straight line or is it curved? Curved. Good. Geometric graphs are curved. Arithmetic graphs are straight lines. Okay, let's do this as a quick example. We've got our sequence of numbers here. Remember, the starting number is always T0, but just read the question. It might say it's the first, but let's just use it as a start. We need to show these numbers in a table. We need to plot the graph, and then we need to describe the graph. Cool. All right, Celine, can you tell me already what's happening to the numbers? Is it going up or going down? It's decreasing. Good. So it's most likely that your graph is going to go downwards, but because it's geometric, it's most likely going to curve downwards. But let's put the numbers in the table first. So let's go to page 20. Next page, guys. We need to plot the numbers in the graph. I'll put it in the table, sorry. So here's our table. Let's fill it in. Remember, at the top is the term number. Not the value, just the number. So let's put our numbers in. So there's T0, T1, T2, T3, and T4. Your table always has to look like this. Okay, and then looking at your values, the starting number was 200. So we put 200 in T0. In T1, it's 120. And then 70 for T2. And then T... 72, sorry. And then what's T3, tell me? 43.2. And then 25.9? 25.92. Thank you. Okay. Now, if I was to ask you, it's not here, but if I was to ask you, how do we find the common ratio here, Abby? Okay, have a think. When it comes to common difference, for arithmetic, yeah, it's any term. It's just right, any term minus the previous. For geometric, it's any term. Divide by the previous. Good. So if you want to find the common difference for the common ratio, it's going to be, I might go T2 divided by T1 as an example. Yeah. So let's put that in. The common difference here would be 72 divided by 120. So it would be 0.6. So that means you're multiplying to get the next number. If it was to ask you, you're timesing it by 0.6 each time. So times 0.6 times 0.6. And does anyone remember what happens when you multiply with a number that's lower than 1? It goes down. Good. And it's more than 1? It's going to go up. Okay, keep that in mind. Cool. Now we graph this. 0.6, yes, it's multiplied by 0.6. All right, now we graph it. So the first number is 0 to 100. So my first number is going to be on this line somewhere. So 0 to 100 will be right there. Easy. Next one is 120. So 120. Should be over here. Number 2 is 272. So 2. And if that's 75 right there, it probably is somewhere here. Okay, 343.2, so that's 40 here, so that's probably about here somewhere. And then you've got number 4 is 25.92. So that would be probably about here. And as per Kane's prediction, it's curving downwards. Yeah, so it's not a straight line. If it was a straight line, the line should follow the line, but this is curving down, as you can see. The interesting thing is, guys, if you actually kept going, did you know that this would never approach zero? Will never ever approach zero. As it'll just keep going low, 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 but never approach zero with the geometrics. So if I was to ask Attila, how would you describe the graph? Not no, you don't. Not skewed. It's curving, so it goes downwards. Just going downwards. Okay, so you'd say downwards, and then Alana said curved or sloping downwards. I would say downwards curve. Or you can even say curving downwards, but overall, I want to see the word downwards. Okay, you must put that in there. All right. Any questions about that one? Not too hard, yeah? Really easy. So, again, quick recap. Arithmetic sequence, you're adding, subtracting, you got the common difference, and then this is how you find it. Yeah, any term minus the previous. Geometric sequence, remember we're just working with multiplication. We're not really going to be dividing with geometrics. We use common ratios, and to find the common ratio, it's any term minus the previous. Now, one other thing remember as well is you'll find that when you do math in year 11, you get a mix of these, geometric and arithmetic. It does form together, so it's not always going to be separate. All right, let's do 3G now. Yeah, so let's go to this page. 3G, slide number 57 or page 29. Okay, shh. Okay, so for this part of the lesson, we're going to learn about recurrence relations. Forget it. Ben, can you remind me or the rest of the class, what's the recurrence relation? We learned about it with the arithmetic sequence. What? Wait. What's a recurrence relation? TO, good. What's TO? Tell me what TO is. What's TO? Starting number. Okay, good. So you got TO, you got to tell me that, and then what do you have to tell me next? Tn plus 1 equals Tn. What do you do with arithmetic or geometric? Multiply. It's going to be times something. So, with geometric sequences, it's basically the same as arithmetic. Instead there of adding and subtracting, we're just multiplying. That's the only difference. So, what I want you to do today, or be able to do today, is I want you to know what a recurrence relation is for geometrics. It's easy. You need to be able to generate a sequence. Donnie. And I want you to create a recurrence relation, right? By the end of today, that's what you need to be able to do. Make the recurrence, make me a sequence of numbers based on the recurrence. That's it. So, actually, we're going to skip this and we'll come back to that shortly. So let's go to this slide, guys, number 60, page 30. So here is a basic geometric sequence. I might ask, let's see, Tiana? That's all right. Tell me look at the numbers. Because I just looked at you. What's the numbers? I see 1. What's next? What's the next number? 3? 9? 27. What's happening with the sequence? Is it going up or going down? Good. It's going upwards. All right. And also, I can see from 1 to 3, is it adding by the same number? Well, let's say it goes up by 2. What happens from 3 to 9? It goes up by 6. And then afterwards it goes up by 18. So it's obviously not arithmetic, yeah? Because these are not the same.
How is it geometric?
How is it geometric? Well, let's have a think. What's happening? What's it going up by? It's going up by different numbers. So that means it can't be arithmetic. But then that means it might be going up by multiplication, okay, because it's increasing. Also, if it's multiplying, is it multiplying by a number higher than 1 or less than 1? Good. It's got to be greater because it's going up. Okay? Shh. So can anyone see what might be happening? It's gone up from 1 to 3. If it's multiplying by something, what do they multiply to get 3? 3. So it's probably multiplying by the number 3. So that means to get the next number, what am I doing? Times it by 3. So that's my general rule here. I'm going to multiply it by 3. So for that question, when it comes to recurrence relations, that number you're multiplying by is what you call the ratio. We all know that already. Yeah, because to get the next number in geometric, you're multiplying by a number of some sort. Now, when it comes to recurrence relations, I'm going to write this back here, and I want you to write this too. For arithmetic recurrence. So for arithmetic recurrence, it looks like this. T0 equals starting number. Or you could call it A as well, that's fine. And then Tn plus 1 is equal to Tn plus D. That's the common difference. That's for arithmetic. Notice how in geometric, it's actually pretty much the same thing. The only thing that changes is this guy, the common ratio. So instead of adding, subtracting, you're just multiplying by the number. That's the only difference. Yeah. So if you already know how to do your arithmetic, the geometric's not that hard. It's the same idea. Okay. So let's actually go and try and figure it out. Are you copying this? I'll fix this up so it's better writing. Common difference. Abby, what's the common difference? Can you remind me? What's the common difference? In general, what's the common difference? What the thing you're adding or subtracting by? That's the number. Up or go down by, yeah. But what's the common ratio? Anyone want to tell me? It's right here. It's the number that you're multiplying by. Okay, that's the common ratio. Alright, let's look at this one. So this is an example of a recurrence relation. Alright, right here. So here, this tells me that the starting number is what? 5. Good. So the starting term is 5. And then to get the next term, this part of the recurrence tells me, so to get the next term, it's going to be whatever you have times by 2. So that means the common ratio is 2. Okay? To get the next number, you're multiplying by 2, which is 10. Yes. So let's generate then the actual sequence. And again, must show working out when it tells you to generate. You have to show this. You have to. So always start out by writing the starting number. Okay, so the starting number is T0, easy. To get the next number, remember you're multiplying by 2. Attila, can you tell me what was the value of T0? 5. So in here we're going to write the number 5. And so Krish, what's 5 times 2 to get T1? 10. Easy. There's your second number. Next one, okay, to get T2, you have to get T1 and times it by 2. Okay, so it's going to be T1, which is 10, times 2, gives you 20. And you repeat the process. So to get T3, okay, you have to get T2 and times it by 2. So that's going to be 20 times 2, so that'll be 40. And then T4, okay, you need T3 for that one. So you're going to get 40 times 2, which will give you 80. Okay, so that's how we generate our sequence. Your answer must look like this. Must. Selenium Van, does that make sense? What did I just say? Your answer, when you generate a sequence, must look like this. Must. Okay. Alright, I want you to try and do these ones on your own. So Attila tells me that for this first one, second one, well, let's do it together first. It's going to be 300. And again, you could use your calculator to do this quickly, yeah? Just replace 300, and then enter, or equals, and then times. What's the common ratio? 0.9. Its first number should be 270. Second number, so you're going to go 270 times 0.9, should be 243. So third number, or T3, sorry, not the third number. 243 should be 218.7. Cool. And then we put that here for T4 to get T4. And then enter, and that's 193.196.83. Abby, are these what you got? Are these the same numbers you got? Easy. I don't know, figure it out. Nah, I'll give you, I'll tell you in a second. Just wait. Alright, shh. Next one. So, question B. Can anyone tell me what's the starting number here? 3. And then what are you multiplying by to get the next number, Esteban? Very good. So on my calculator, you're just going to write the number 3 first. Press equals. And then you're going to go times 1.5 to get the next number. So it should be 4.5. So T1 is 4.5. Oh, sorry. 3 times 1.5, which is 4.5. And then to get T2, you're going to use 4.5 on your calculator. Double check, man. So for T3, same deal. I'm going to round this to 2 decimals, so 10.13. And this will be 10.13, 15.19. That's fine. You can. It does say to round to 2 decimals. So 1875 becomes. That's all right. That's all right. It becomes 1.9. 15.19. Cool. All right. That's how we generate a sequence. It's not hard. All right. So next thing is now we're going to create the sequence. It's not hard to do either. When you're creating a sequence, it's the same idea. Just tell me the starting number. Tell me what it is you're multiplying by to get the next number. Yeah. Again, your answer has to look like this. Must look like this. You can't just write A and whatever the common ratio is. It has to look like this. All right. So here's the sequence. Nice and easy. We need to create a recurrence relation that models this sequence. And you know what? In year 11, you'll see a question that looks exactly like this all the time. Models the following sequence. It just means make a recurrence relation based off these numbers. That's all that means. All right, shh. All right, Karan, can you tell me what is the value of my starting number? Easy. All right, we'll go 500 for A. Okay, and then the next step would be we need to find what am I looking for, guys? Good. Well, actually, before I look into that, I need to find my common ratio. Yeah. So, Abby, this is where you were asking me how do I get the common ratio? Remember, it's any term divided by the previous term. Can you pick for me, Tommy, a number in this sequence? 0.2. Yep. Just wait, Tommy. Fine. Let's go with Krish. Can you pick a number for me in this sequence? Any number? 720. So Krish is going to use T2. And what are you dividing it by? Which is T1. So it's going to be 720 divided by 600, which equals 1.2. Good. So my common ratio is 1.2. So what this is saying is, to get the next number, you're just multiplying by 1.2. Alright, so putting that all together in my recurrence relation, my starting number is 500. Okay, 500. And I'm multiplying by 1.2. Alright, so on I think it was Friday last week, we had started learning about our geometric sequences. Good. So Donny, can you remind the class what is a geometric sequence?
Going up by multiplication.
So when it goes up or down using multiplication or divide, but what are we using for year 10? Just multiplication, yeah? What happens, Akela, when you multiply with a number bigger than 1? It goes up. And then if you multiply with a number less than 1, it's going to go down. That's why we're using multiply only, because you're going to use numbers that are going to go up or greater than 1 or less than 1. Alright, so we started learning about the finding of the recurrence relation. So remember, a recurrence relation just tells you what's the starting number and then how do you get the next number. Alright, so in this case, for a geometric sequence, you're telling me similar thing, what's the starting number and then what are you multiplying by? Alright, so for this question, Krish, can you tell me what's a starting number? 1,000. Good. So that's nice and easy. We'll just go with 1,000. Now the next thing we need to look for is something called the common what? Ratio. Okay, Karan, how do you find the common ratio?
It's 0.7.
But tell me how. Give me the steps. It's any term?
Any term divided by.
Good. Divide by the one before it. So previous. So if you're going to use T4, then you need to use T3 as the one before. If you're going to use T5, then use the one before, which is T4. In this case, I'm going to go with, you guys want to pick one for me or whatever? T3, all right. So it's going to be I'll write the whole thing. So T3 divided by T2 because it's the one before it. So let's go 421.875 divided by 562.5. So if you get your calculator out for that, if you get confused, you can use your fraction button, but it's the same as divide, yeah? So 421.875 divided by 562.5, and it equals 3/4, which is 0.75. So what's going to happen to the numbers, guys? Going down. I like it. Because it's less than 1, your terms should go down. Okay, that's what our sequence will look like here. All right, now, in the actual sack, remember, when you do a recurrence relation, it has to look like this. You have to write everything. So that's why I didn't put all the T zeros and T that here, because I want you to do it. So as an answer, remember, for a recurrence relation, you have to tell me what's T0, and then Tn plus 1 equals Tn times, and then whatever the common ratio is. Alright, Tiana, can you tell me what's our starting number in this sequence here? Easy, alright? That's nice and easy. So that's literally 1 mark that you'll get if you start with that. Most recurrence questions or recurrence relation questions are worth 2 marks. Okay, 1 is giving me the starting number and then the common ratio. So, Kane, can you pick a number from this sequence that we can use? Any number. Which one? T2? Alright, cool. So we're going to go T2 divided by T1 because it's always the one before it. So 2.25 divided by 1.5. So the ratio should be 2.25 divided by 1.5. 3/2, which should be 1.5. Yep, cool. 1.5. So my common ratio is 1.5. Okay, that's what your recurrence relation must look like. All right. Any questions? Any questions? Any questions? Not too hard here. Recurrence relation, nice and easy. Just give me the starting number and then how to get the next number. Now, stay on this page because I'm going to go back a little bit so you don't have to. We're going to start the next thing. And I don't know why the notes made it so that it's here, but over here. Now we're going to look at a percentage change. So this kind of relates to what I talked to you about. What happens when you multiply with a number bigger than 1 or less than 1? So when you're reading a question, and you need to read it properly, if the question is saying that it's going to increase, okay, then this is what we're going to be looking at. Okay, and what this is it's basically helping you find the common ratio on a percentage increase or decrease in fall. And you're going to get questions like that. If a question is going to be a decreasing, okay, so this is what we use for a common ratio that's decreasing. Okay, so this is slightly different to your normal anytime divided by previous. So this is just when you're working with percentages that are increasing or percentages that are decreasing. Okay, so let's actually see how that works. Let's go to the next page, which is page 36. Once this loads over here. Oh, sorry, page 35. Okay, so let's look at this example. It says here Guido measures his car petrol usage and finds that at the end of the first day, he's got this much left in the tank. He records his usage for the next few days and finds that he uses 15% of what's left in the tank at the start of each day. So, Sporry, you haven't been here, right? But if I was to ask you, logically speaking, what's happening in this scenario? Is his petrol amount increasing or decreasing? Decreasing. So, that being said, remember the two R ratio rules that we've got. For increasing, it's 1 plus percentage over 100. But if it's decreasing, what are we going to use? 1 minus percentage over 100. So in this scenario, we're going to be using this formula, this ratio of 1 minus, because it's going down. Okay? Question A, we need to find a recurrence relation that models his petrol usage. So it's the same as what you normally would have. Any recurrence relation, yeah? So you're going to tell me what is T0, okay? And then Tn plus 1, you're going to tell me what is the common ratio. So two things. All right, so this one's a bit tricky, yeah, because the way it words it is at the end of the first day, he has 550 liters left in the tank. Some of you might get confused, but in this case, we're going to use that as technically the start. Okay, so we're just going to write 550 there. Okay, we'll make that the starting term. Now, what we need to find next is we need to find the common ratio here. We don't know it. Okay, because we've read this and it's going to be decreasing, I'm going to be using that formula, okay, to find out common ratio. So here it's going to be 1 take away. Can anyone tell me the percentage decrease? 15. So it's 1 take away 15 over 100. Okay. Now when I put that in my calculator, okay, 1 take away, and then use your fraction button if you're confused. 15 over 100. Okay, it will be 0.85. So there's my common ratio, 0.85. Okay, while you're writing this, okay, actually, Lizzie, I haven't asked you yet. What does this recurrence relation tell us? What does it tell you? What's the starting number? What's the starting number in my recurrence? So what does this all tell you? Good, and how do you get the next number? Good, you're timesing, so to get the next number, you're just going to multiply by 0.85. And remember, because it's a number less than 1, it's just going to keep decreasing. Okay? Let's see if there's space for B. Say that again. Because it's a percentage. So this rule here, these two rules, only apply when it's a percentage change. Okay? And it'll be very obvious that it's changing by that amount. All right. So that's part A, nice and easy. Let's fill it in here if you want. So 15. Okay, and we know that that's 0.85. Okay, nice and easy. Okay, let's do part B. So we know that the starting amount is 550 and the ratio is 0.85. Alright, so now the next question is we need to tell us how much he's got after the end of the first 5 days to 2 decimal points. So this part of the question is pretty much the same as generate the first 5 numbers of your sequence. It's just in a worded form. Okay, so you might need your calculator for this. So if you get your calculator out, actually let me fix this up. Thank you. Okay, let me have this here so it's all ready. So for this one, you're just again going to use a calculator. Show you're working out though, yeah? Because if you want your top marks, or if you want full marks for this, that's what we're going to look for. Yes.
It says two decimal places here, but do you want me to round the second one up or down, or just leave it as normal?
So it depends what the number is. Let's go.
375. Underneath the 7.
Well, let me go through it with you, man, so we can see. So starting number is 550. If you wanted to actually do it on your calculator really quickly, you could go and just press enter equals and then times 0.85 to get the next number. So in this case, it's 467.5. So 550 times 0.85. Yes. Shh. Thank you, guys. Yeah, technically. That should be T2, sorry. Thank you. Good find. That is a typo, and this should be. Yo. Yeah, yep. One at a time. So the next one is going to be 4. Oh, where my pen go? Just make this smaller. So 467.5 times 0.85, and it should give you the next number, which is 397. So your question, Tommy, is do I round that 7? Make it an 8. Because you got to round. See that 5 will affect that 7. No, you got to round it. You might not get the full mark if you don't round it properly. Next one is 337. Oh, so this is going to be 397.
So, sir,
Yes.
will you get like full mark down? So, say we do 550.
Yep.
And then multiply by 0.85, and then you round that, but you don't have to round the number in the calculator. You just do the number
In year 10, I'm quite lenient, but in year 11 and year 12, they're very strict with rounding. Because that's how they differentiate people from getting good study scores to not so good. It's mean, I know, but we're not the ones that do your exams in year 11.
Wait, so like if you do 550 and then multiply by 0.85, multiply by 0.85,
Ah,
or do you do like
the new number.
467?
Yeah, so I would say that just you can round these answers only, but stick to what you're doing in the calculator. Does that make sense? Uh, oh, sorry. Okay. Any questions, guys? Any questions? Does that all make sense with the percentage change? I won't do that one. Any questions with it? So just read the question. It will tell you whether it's increasing or decreasing. You got to use the appropriate one, and that becomes your common ratio. All right, I think I'm gonna leave it at that. I won't do this one because it's a calculator. You guys get it. Yep. Cool. All right. Last thing. Final thing, guys. So remember recurrence relation. Remember, it just tells you what's the starting number, what's the common ratio, and the other main thing you got to remember is the percentage changes. So, Krish, can you tell me if you have a percentage increase, which of these formulas do you use? On the left. And if it's a percentage decrease, or on the right? Good. All right.